Hello everyone. Let's take a look at our next problem. Okay, so we have a to the power of b is equal to b to the power of a. So the first thing I'm thinking, we'll have to be careful about negative numbers raised to certain exponents. For the moment, let's only think about positive values of a and b. Certainly, any two values of a and b which are equal, which will make this true as long as a to the power of b is defined. So for example, if a and b are both 3, then I get 3 cubed equals 3 cubed. I might have to break this down into cases for things such as, a and b not equal to 0. Well, actually, we can rule out 0 pretty quickly. If a equals 0, then as long as, let's say a equals 0 and b is not 0, but I suppose we need b strictly greater than 0. So this implies a to the b equals 0 and b to the a equals 1. Okay, so a cannot be 0. A can't be 0 if b is strictly positive. And of course, vice versa, this is also true. So I suppose we can allow, we can rule out if b is equal to 0. 0 to the 0 we'll assume is undefined. We're not, it is undefined. If a is 0 and b is negative, again, we have something undefined. So neither of them can be 0. All right, so what do we have here? We definitely have a not equal to 0 and b not equal to 0. This is certainly true. So we can forget about zeros now. I might want to just take some logarithms and see what happens. If I do that, so then I have b log a is equal to a log b, which gives b over a is log b over log a, or equivalently base a log of b. Does this help? Or maybe it's better to write log b divided by b is equal to log a divided by a. So we see again, a equals b is going to be a solution of this. Maybe what I want to do now, because I have an expression in terms of only b and an expression in terms of only a. I want to look at this as being, I want to look at this function. So I'm going to define this function f of x log x divided by x. And what when I look at this, what I'm trying to do is I want to find two different values of x, so this thing is equal. If I have two different values of x where this thing is equal, then I have a solution to this for different values of a and b. So what does this look like? Okay, well, let's just sketch off some key points here. Suppose it's probably going to go down to negatives like this. Okay, so when x is equal to 1, this thing is equal to 0. As x goes to 0, This must be going down to negative infinity. And there's certainly going to be, so it's positive to the right of 1. And as I take a limit, if I take a limit as x goes to infinity, then this approaches 0. It probably only has one maximum, but to check that, let's take a derivative. I'm going to rewrite this as a product. So what do I have here? I have 1 minus log x divided by x squared. And so this is equal to 0 only when log x is equal to 1, or when x is equal to e. So we have a point here where it reaches the maximum at e, and then it comes back down and goes to goes to 0. So if I draw a horizontal line anywhere, I'm going to get two different values of x, where the value of the function f is the same. So is there a way of relating those two values of x on either side here? I don't know if it's not sure. A to the b is equal to b to the a. If I know what a is and try and solve for b, let's think about it that way. I'm trying to solve for b log a minus a log b equals 0. Will this help? I'm not really sure. So we know that, for any choice of x greater than 1, or for any choice of a greater than 1, there's going to be a value of b which is greater than e, which will satisfy the equality. But how do we actually get that value? All right, well, what I definitely have here is I have a equals b works for all positive a and b. If either a or b are less than 1, I should, I suppose, less than or equal to 1, then a equals b is only solution. Right, that comes from just looking at the figure, looking at the plot of log x over x. Right, if I choose a, say, to be this point here, then that's going to be the only value of b, which makes these two things equal. A equals e implies b is equal to e. And for a strictly between 1 and e, there exists unique b greater than e, such that a to the b is equal to b to the a. I don't know at this point yet how to actually, if I'm given this value of a, how do we actually find this value of b? Maybe there's some clever thing that can be done. It's not really a standard form of an equation that I'd want to solve, or that I know how to solve. I'd have to think about it a little bit more. But for now, that's about as far as I can get. Maybe I'll return to this one if I think of a way of sort of inverting this. Given one of these, how do I solve for the other? Thanks for watching.